All right, section 1.2, algebra 2, where transformations of linear and absolute value functions. Our objective for today is to be able to write functions representing translations, reflections, stretches, and shrinks. Okay, and write functions representing a combination of these transformations. Okay, so from our previous exploration, we did a little playing around in Desmos and noticed that when we took a function and added within that function, if we added onto the x, it moved it left and right. Okay, but what we notice is it actually moved it left and right backwards. So here we're going to go ahead and create a rule to describe our horizontal translation. So horizontal translation is moving it left or right. So if I want to take my original parent function, so let's say my original parent function is f of x equals, and I'm just going to leave it blank, f of x equals something. If I want to take that function and I want to move it left or right, okay, I have to add and subtract within the function. But it's important to notice that whenever you do anything horizontally, left or right, horizontal always works backwards. It does the opposite of what you think it would do. Meaning, you would think if you would add 6, it would move it to the right 6, but it doesn't. It moves it backwards. So if I want to move it to the right, so let's go ahead and if I want to move it to the right, I would need to take this function, and inside the function, if I'm moving right, it's going to go backwards. I need to subtract a certain value h. So here, this is moving it right h. Oh, sorry, I don't know what happened there. Moving it right h units. So what that's going to do is if I go ahead and I draw in, let's just do with my absolute value function. So here's my absolute value function. So for example, if I have my function equals the absolute value of x, if I want to move it to the right, let's say 3 units, my new function then would have to be, my new function, I would need to take my old function, my f, and subtract 3 if we want to go 3 units. So I'd have the absolute value of x minus 3. That would move it to the right to 3 units. So my new absolute value function would be over there. Again, that's if I'm moving it to the right. Okay. Now, if I want to move it to the left, h units. Okay. Then, so we're going now to the left. I would need to take my original function x and add h inside that function. F of x plus h. So really what this is meaning is I'm just putting this x plus h here into this original function for x. So instead of just placing an x inside that function, I put an x plus h inside that function. So here, if I wanted to move this now to the left, let's go the left 4 units. Okay, my new function h of x would be, I would take my f function and x minus 4. Oh, I forgot the absolute value on this guy here. Sorry. Okay. So it would be the absolute value, plus 4, x, absolute value. Ooh, geez. All right, scratch that. So if I wanted to take this original function, my f function, and move it to the left 4 units, I would need to add 4. Again, because horizontal always works backwards. And you'll see that when we're doing stretches and shrinks as well. Horizontal always works backwards. Okay, so it'd be the absolute value of x plus 4. There in absolute values. Okay. Okay. Oh, sorry for that Pareto-Bidosari thing in the way. But it's the absolute value of x plus 4. Okay. All right. Okay, so vertical translations then, again, vertical, remember, is up and down. So here, if we want to translate our function up or down, it works exactly how you would think it would. If my original function is f of x equals something, then if I want to move it up h units, oh, let's switch colors, sorry. If I want to move it up h units, okay, I would take my original function and just add h on the end. So here I'm not adding the h to the x, I'm adding it out to the end. Okay, so that would move it up h units. Okay, so again, if my function was the absolute value of x, which that parent function would look like that, if I want to move it, let's say, up 3, then my new function, my g of x, would have to take my original function, my f of x, and just add a 3 onto the end. So it'd be the absolute value of x there contained, and then just add a 3 on the end. So that would move it up 1, 2, 3. Oh, straight lines. Ooh, that's bad. Let's erase that. 1, 2, 3. Having a hard time there, guys. There we go. Okay. So now if I want to move down h units, okay, it's just like you'd think it would. I take my original function and we subtract h. So that moves it down. So now if I wanted to take, again, my original absolute value function here, this original guy, and let's say I want to move it down 5 units, my new function, my h of x, would be I take my original function, my f of x, and move it down 5 minus 5, so it'd be the absolute value of x minus 5. I love moving up and down. It's so easy. You just add it on to the end. You add to move up, or subtract to move it down. There on the end. Okay, so there's translations, aka that's just this translation was your elementary word of slide. Back in elementary, you called it a slide. We kind of move up and get a few more syllables in those words. We call it a translation instead. Okay. All right, so let's do an example. So here's my original function. So this right here is my parent function. Oh, there's my parent function. F of x equals 2x plus 1. So we want to write a function g. So we're writing a new function. We're going to name it g, whose graph is a translation. We want to go 3 units down of the graph of f. So I want to take this f function, whatever it looks like, and move it 3 units down. So moving down, that's a vertical. So if we come back here, a vertical translation, if I want to move down, I take my original function and subtract however far down I want to go. So here, to get to my new function g, my g of x, I would need to take my f of x, and if I wanted to go 3 units down, I'd need to subtract a 3 on the end. So this here, what I just wrote, this guy right here is really just my plan for what I'm going to do. I'm going to come up with a new function, which takes my original function and moves it down 3. So it's subtracting 3 on the end. So now I'm actually going to do it. So now I'm going to come up here and I'm going to take here my f of x and I replace it with my f of x. My f of x is 2x plus 1. So I'd have 2x plus 1. There's my f of x, and then I want to subtract 3. So now I just take this guy that I have right here and simplify him. So I have 2x plus 1 minus 3, so I can go ahead and put these two guys together. So I'll end up with 2x minus 2. So that's my new g of x function. Oh, didn't leave myself much room. So there is my new answer. G of x equals 2x minus 2. So how these two graphs are going to be related, if I was to graph this in my calculator and graph this on graph paper, graph them both on graph paper, this guy would be 3 units above this guy, because this guy would be 3 units down of the original, because that's what I wanted to do, move it 3 units down. Okay. Example 1b. Write a function h whose graph is a translation 2 units to the left of the graph of f. So now I want to come up with a new function h, so let's name him h of x, and it wants to take the function f up here, and it wants to move it 2 units to the left. So let's come back here. If I want to go to the left 2 units, I would need to add 2 inside my function. So I would need to take my function f and add 2 inside of it. So instead of f of x, I'm going to need f of x plus 2. So this is different than adding the 2. Like up here, we just subtracted the 3 on the end because we were moving up and down. Here, if you're moving left and right, again, it moves backwards. So to go to the left, you need to add 2, okay, because left is negative, so you're going to go positive instead. Okay, so horizontal always works backwards. But this is me putting x plus 2 into my function for f. I'm taking this guy and putting him in this function up here for x. So instead of 2x, instead of 2 times x like I have up here, I'm going to have 2 times this guy. Okay, so it'll be a little different when I put it in. So because my function, my f, is 2 times x plus 1. So I'm going to have 2 times, but instead of x, I'm putting this x plus 2 in there. So I have 2 times x plus 2 plus 1. So if you notice, this new function and this one are the same, except for instead of an x, I replace it with an x plus 2. So I actually have to distribute here. I have to take this 2 and distribute it in there. So that would give me 2x plus 4 plus 1. Then I can put these two guys together. So my new function, my h of x, is equal to 2x plus 5. And there's my answer. So again, my original function here, this f of x equals 2x plus 1. This new function is me just taking this original one and moving it 2 units to the left. So if I was to graph the two, this would be 2 units to the left of that one. Okay, so there's translations. Okay, reflections. Okay, mainly we're going to be doing reflections in 2 different axes. Basically, a reflection was your elementary word for reflection was a flip. You call them a flip. We're basically going to be flipping these graphs over. Hey, we're going to be flipping them over. You need to know what line to flip them over. Like, am I flipping up and down? Am I flipping left and right? We're going to flip over the 2 axes, the x-axis and the y-axis. Okay. If you flip over the x-axis, okay, to flip over the x-axis, what you do, my original function is just f of x. So there's my original, aka this is my parent function right there. If my parent is f of x, for reflection in the x-axis, its child, if I want to flip it over, so if I want to flip it over the x-axis, so here's my parent, we'll just say it's this random function, which of course we know is an absolute value function. Okay, if I want to flip it over the x-axis, I multiply by a negative out front, so it's the negative of f of x. So basically, I multiply out front by a negative, and that will flip this over the x-axis. It basically flips it down here. So then now it would look like that. Flip it over. So again, you put that negative out front. So I don't put, if I want to reflect over the x-axis, I don't put the negative on the x. I put it out front. Now, if I want to reflect over the y-axis, so again, here's my parent. Oh, we better not use that for a parent. Because it's kind of boring. Ooh. Oh, forward. Sorry, I'm getting rid of stuff. Okay, let's say I want to reflect over the, let's do this line here. And I now want to reflect over the y-axis. Again, the y-axis is this guy right here. Okay, I want to flip it over that, so I want to actually flip it this direction. To flip it over the y-axis, I put the negative inside on the x, so it'd be f of negative x. So I basically, I like to put a times in there, negative times x. So basically, I put a negative x in for all of my x's. And what it does is it'll then graph a reflection. So in this point there, we'll have that point there, and it'll kind of look like that guy if I flip it over like that. So that's the reflection in the y-axis. Okay, for example, here is my parent function. So there's my parent function right there. F of x equals the absolute value of x plus 3, plus 1. We want to write a function g whose graph is a reflection in the x-axis. So here we're reflecting in the x-axis. So let's flip over. X-axis, I put the negative out front of the whole entire function. This negative is out front of this negative here is out front this whole function. Okay, so I have to do it out front the whole thing. So, and I want to name it g. Okay, so we'll go g of x. Kind of short on room here. Let's go ahead and let's put it down here. So here's a. So my g of x then would be a negative out front of f of x, the whole f of x. So now I take my f of x from up here and I put it in there. So I'm going to have the negative of, and I'm putting in parentheses to make sure I do the whole thing, the absolute value of x plus 3 plus 1. So I want the negative of that whole thing. So basically I'll have the negative, and again, so I have a plus sign right here. I have a plus sign right there. So I'd have to take this negative and distribute it among these two things, this thing and that thing. So this negative is going to go to this thing and that thing. So I'll have a negative, the absolute value of x plus 3, and a negative now 1, minus 1. So there's my new function, my g of x. Oh, equals. So this, and I could check with Desmos and see, but this and this are just reflections over the x-axis of each other. Okay. So now if I want to, on the next one here, let's switch colors to help us. So on this next one, write a function h whose graph was a reflection in the y-axis of the graph. So if I want to reflect over the y-axis, my new h would be f of negative x. So now here, instead of putting the negative out front, I want to put the negative in here on the x. So I take my original function up here, and I replace this x with a negative x. So I would replace my x with a negative x. So I have the absolute value of, instead of x, we'd have negative x plus 3 plus 1. Well, I don't see any simplifying I can do with that guy. So there's my answer. There's my h of x right there. Okay, next. Horizontal stretches and shrinks. Remember earlier when I said horizontal works backwards? Yep, these work backwards as well. Multiplying by a big number actually shrinks it, and multiplying by a small number actually stretches it. A horizontal stretch and shrink actually stretches it this direction. It pulls all of the points the same amount to the left and to the right. So basically imagine like a Stretch Armstrong here in the middle. There's a Stretch Armstrong guy here in the middle. And I'm going to take him and I'm going to pull all the points out the same number, by the same factor. I'm going to make him pull it out twice as far, 3 times as far. Or I might squeeze it in and squeeze him in the same distance. Okay. Hey, but again, horizontal stretches and shrinks work backwards. Okay. What that means is if I multiply by a small number, it's actually going to stretch it. So if I want a new function and I want to stretch or shrink it horizontally, left or right, pull it to the side like that, I take my function and I multiply by a number inside the function. So a times x. So I'm multiplying inside the function. Just like here for our horizontal translations, we added or subtracted inside the function for a horizontal translation. For a horizontal stretch or shrink, we multiply inside the function. But again, it works backwards. If this a value, if a is less than 1, meaning some kind of fraction, aka a fraction, it's actually going to stretch it by 1 over a, the reciprocal. Okay, so if a is a small fraction, like let's say it's 1/2. For example, if a is a half, it's going to stretch it by a factor of 2. Basically, it's going to be twice as big. It's going to stretch it twice as far because we flip it. Okay, so it gets flipped. So it's actually going to be stretched by a factor of 2 over 1. Twice as big. Okay, so then if a is greater than 1, then it's going to be a shrink. Again, a shrink by 1 over a. So if let's say it's 6, it's going to make it, again, that'd be 6 over 1. Again, it flips it. It's going to make it 1/6 as big. Okay, so again, that horizontal works backwards. And we'll have a lot of practice with that this year. Okay. Vertical stretches and shrinks, okay, work just like our vertical translations, meaning you add it there on the outside. So here we're going to multiply on the outside. And we multiply on the outside, we write it out front. So I take a times f of x. Okay, so I'm multiplying. Again, this is going to take this Stretch Armstrong guy, my function, and it's going to stretch him up or down, or it's going to push him and squeeze him down towards the axis. Okay, depending on if whatever a is. Here, if a is greater than 1, a whole number, it's going to stretch it. Stretch by a. So if a is 2, it's going to make it twice. It's going to stretch it 2 times out. Okay, twice as far. Okay, if a is less than 1, okay, then it's going to shrink it again by a. Okay, so stretch by a, so let's say it's 3. It'll make it 3 times as big. If a is less than 1, like say 1/3, it's going to make it 1/3 as big. It's going to push it in by a factor of 3, 1/3 as big. Okay, all right, so let's go ahead and let's do an example. Okay, example 3. Okay, let f of x be the absolute value of x minus 3 minus 5. So now we want to write a function, g, so that's our new function name. We want a horizontal shrink by a factor of 1/3. So if we go back here and we have a horizontal shrink, again, horizontal shrink works backwards. So if I want to shrink it by 1/3, I'm going to have to multiply by the reciprocal. So if I want to shrink it by 1/3, it's horizontal. So that tells me, if it's horizontal, that tells me it works backwards. Oh, sorry for the static there. So if it's horizontal, that tells me it works backwards, which tells me that instead of multiplying by 1/3, I'm going to have to flip it and multiply by 3. Well, 3 over 1, which is the same as 3. And horizontal, again, works inside the function right there, multiply by a. So I want my new function g then, g of x, to take f and multiply inside by 3. So 3x, f of 3x. So that tells me I take this original function here, and instead of x's, I put in 3x's. So my new function would be absolute value 3x minus 3 minus 5. All I did is replace this x with a 3x, and that will make it shrink it horizontally, meaning it's pushing it in from the left, it's pushing it in from the left and from the right by a factor of 3. So there's my new function, my g of x. Okay, all right, next one, part B. We want to do and a function h, whose graph we want a vertical stretch by a factor of 2. Well, vertical works how you think it would. So my h of x, again, look back in our notes, vertical stretch, I multiply out front by what I want to stretch by. I want to stretch it by a factor of 2, so I'm going to take 2 times my function f of x. But again, it's 2 times that whole function, so I want to take 2 times this whole thing. So I'd have to take 2 times that whole function, which is the absolute value of x minus 3 minus 5. So again, I have to kind of distribute that 2 in, the 2 to this thing, and the 2 to that negative 5. So I'd have 2, absolute value of x minus 3. You can't distribute into an absolute value. Well, you kind of can, but we're not gonna. That's just confusing right now. So here's my new function. So this function has a vertical stretch, stretching it up and down by a factor of 2. So basically it just stretches it twice as far from that x-axis. Okay. All right, so combining transformations. It's extremely important when combining transformations to not try to do everything at once. Do one thing at a time. Okay, so here we're taking my parent function. Let the graph of g be a vertical shrink. So we want to do a shrink. We better even label it vertical. So I'm going to kind of label 3 different, so we want to do, we're kind of going to do 3 different columns. We'll have our parent function. So let's do 3 columns. So we're going to have our parent. And then we want to do a vert shrink by 2. Oh, sorry, 0.25. And then 3 units up, and then 3 up. We're only going to do one thing at a time. I'm going to switch colors, kind of help us out a bit. We're only going to do one thing at a time. Okay, so first of all, my parent function is f of x equals x. Well, that's a nice parent function. So if I want to do a vertical shrink by 0.25, so a vertical shrink, I just multiply out front by 0.25. So let's take this original function. So I want to multiply this function out front by 0.25. So I want to take 1.25 times my f of x. Well, my f of x is just x right here, so I'll just have 0.25 x. So this is the new function I'm working with. So this is the function that I'll take over. This is my new, I don't know, let's call it g of x. That's my new g of x. So now we want to shift this guy up 3. So if we don't remember, we can look back in our notes. If I want to shift up 3, I just add 3 onto the end. So I want to take this function here, I want to take my g of x and move it up 3. So now I put my g of x in there, which is its 0.25x. We want to move it up 3. So this is my new, completely new function. It says to label it, rule it g. So my new function is 0.25x plus 3. Okay. Oh, no, too far. All right, last one, example 5. You design a computer game. Your revenue for X downloads is given by this function. So they give us a nice little function there. Your profit is $50 less than 90% of the revenue for X downloads. Describe how to transform the graph of F to model the profit. What is your profit for 100 downloads? Okay, so there's our original function, or there's our parent function. Okay, so this means that I design computer games, and for every download, okay, so if I had 1 download, I'd make $2. If I had 2 downloads, I put a 2 in, I'd make $4, so forth and so on. So I just put in, if I downloaded so many, that would be my revenue, the money coming in. Okay, that doesn't necessarily mean that's all I get to keep. My profit is I have to subtract all my expenses. So this is my revenue, and they say for my profit, let's write down what we know. For my profit, it's $50 less than. So less than, to me, that idea less than means I'm going to subtract $50. So that $50 less than tells me I'm going to be subtracting $50 with that $50 less than. And then for that 90% of the revenue bit, I want 90% of my revenue. Well, my revenue is this guy right here. So I want 90% of that function. So 90%, I'd need to multiply by 0.90. That's 90%. Again, 90% is the same as 0.90. Move the decimal over 2 places per 100. Of the revenue. Well, my original revenue was my f of x. So if you notice here, this negative 50 is going to, this negative 50 right here is going to shift this thing, this guy is going to shift it down 50, because it says to describe how to transform the graph of F to model the profit. So we'd have to go down 50. And then this multiplied by 90 out front, I'm multiplying out front by 0.90. Multiplying out front there tells me it's a vertical stretch or shrink. 0.90 is less than 1, so it's going to be a vertical shrink by 0.90. So this guy here is a vertical shrink by 0.90. So there is my profit function, and here I've described how to transform the graph of F to model the profit. I would need to shrink it vertically by 0.9 and shift it down 50. So there's my new profit function. So let's go ahead and let's label my profit function. My P of X profit function is 0.90. My F of X there is 2X. I'm just replacing that F of X right here with what F of X is up here. I'm replacing this F of X with that F of X is 2X, so times 2X. Ooh, out of room, minus 50. So 0.90 times 2X, so 0.90 times 2 is 1.8, so we'd have 1.8x minus 50. So that's my profit function. That tells me, based on how many video games I sell, how much money I actually make. They're asking, what is your profit for 100 downloads? So basically, I'm trying to figure out when my x is 100. So P of 100 would equal, oh sorry, I need an equal sign there, 1.8 times 100 minus 50. 1.8 times 100 is 180. I knew that one. Minus 50 is 130. So my profit is $130. So geez, if 100 people downloaded it, I'd only make 130 bucks. Okay, there's my profit. Okay, so now you have some your turn problems to do. Get those done, check them with a classmate and your teacher, and then go ahead and after you get the your turn done, then go ahead and do your practice. Prepare yourself for that skill check.